Earth moves through space at about 30 kilometers per second, which is roughly 67,000 miles per hr. This speed is constant and steady, and because everything on the planet moves with it, we do not feel it. The air, oceans, and land all move together. So to us, it feels like we are standing still. Now imagine that this motion stopped in an instant, like slamming the brakes on a speeding car. The effects would be catastrophic on a level far beyond anything humans have experienced. Think about what happens when a car crashes. If you are inside and the car hits something, the car stops, but your body keeps moving forward at the same speed. That is why seatbelts exist, to hold you back and spread out the force. If the Earth stopped, there would be no seatbelt. Everything not anchored deep into the planet would keep moving at 30 kilometers per second. That includes people, animals, cars, houses, lakes, oceans, and even the atmosphere itself. The first thing that would happen is the air would not stop with the ground. It would rush forward at incredible speed, creating winds so powerful they would strip buildings down to their foundations. A hurricane has winds of around 250 kilometers per hr at most. These winds would be over 400 times faster. The force would crush cities, forests, and mountains. Even the tallest skyscrapers would not stand for more than a fraction of a second. The oceans would surge forward like a giant wall of water, far higher than any tsunami. Coastal areas would be swept clean of land and life in moments. Ships and submarines would be hurled across continents like toys. Even inland rivers and lakes would behave like liquid bullets, ripping through valleys and plains. The sheer speed of the water would turn it into something more like sandblasting than a wave. Anything in its path would be destroyed instantly. Humans and animals would have no chance. If you were standing outside, you would be thrown forward at 30 kilometers per second. For perspective, a bullet from a high-powered rifle travels at about 1 kilometer per second. This means your body would be moving 30 times faster than a bullet. The ground would strike you with such force that you would disintegrate on impact. Buildings would not protect anyone. As the walls and ceilings moved at that speed, they would tear apart into shards and crush anyone inside. Vehicles like airplanes or cars would keep moving in the same direction they were traveling when the planet stopped. Planes would fall from the sky like stones, but even before hitting the ground, the violent air currents would tear them apart. Cars and trains would shoot off roads and tracks, continuing at their original speed until they smashed into something, releasing a massive burst of energy on impact. This event would also generate incredible heat. When objects move at high speeds and then stop suddenly, the energy has to go somewhere. Friction would turn much of it into heat. The atmosphere itself would become so hot that it would ignite in many places. Forests, grasslands, and cities would catch fire. The surface of the Earth might even scorch and melt in some regions, similar to the way a spacecraft heats up when entering the atmosphere. The Earth's crust would suffer damage as well. The sudden stop would cause massive earthquakes, far beyond anything recorded. Tectonic plates would lurch violently, creating cracks and fissures hundreds of kilometers long. Volcanoes would erupt as magma forced its way to the surface. Entire mountain ranges might collapse. This would add to the chaos as ash and lava spread across continents. Imagine standing on a train moving smoothly at high speed. If the train stops gently, you barely notice. If it stops suddenly, you are thrown forward and might fall. Now, scale that up to the size of the entire planet. The inertia of everything on Earth would act like that sudden forward motion, except at unimaginable speed. There would be no time to react, no chance to run, no save. Even space itself would play a role. Satellites orbiting Earth would keep moving as the planet stopped, and they would crash into the surface or into each other. Debris from these collisions would rain down through the atmosphere, burning up and adding to the destruction. The moon, however, would not stop. It would continue moving around the Earth, and this sudden mismatch could destabilize its orbit. Over time, this might lead to further catastrophic effects, including the moon crashing into Earth or drifting away entirely. The sudden stop would also affect Earth's magnetic field. The molten iron core inside the planet spins and helps generate this field. If the crust stopped while the core kept moving, the interaction could cause a temporary collapse of the magnetic field. This would leave the surface unprotected from solar radiation. Anyone who somehow survived the initial destruction would then face deadly radiation from space. If you think about energy, you can see how much power is involved. The kinetic energy of all moving objects on Earth is almost impossible to imagine. It is far greater than the total energy of all the nuclear weapons ever built combined. When that energy is released in a single instant, the result would be total annihilation of life as we know it. To make it more relatable, imagine standing near a dam holding back a vast lake. If the dam breaks, the water rushes forward and sweeps everything away. In this case, instead of water, it is the momentum of the entire planet being released at once. No structure, no matter how strong, could withstand it. After the initial destruction, the planet would continue to suffer. The atmosphere might eventually settle, but it would be filled with smoke, dust, and ash, blocking sunlight. This would lead to a deep freeze as temperatures plunged. The sudden shift in weather would kill most remaining plants and animals. The oceans would take centuries to return to anything close to normal. Life, if any remained, would struggle to survive in a hostile, barren world. This scenario is purely theoretical. In reality, there is no known force that could stop Earth's motion instantly. Space is vast and empty, and even collisions with other celestial bodies happen over time. Not in an instant, but thinking about it helps us understand the role of motion and inertia in keeping our planet stable. It also shows how delicate our existence is, balanced on a moving sphere traveling through space at incredible speed. When Earth moves through space, everything on the surface moves with it. The ground beneath us feels steady, but that is only because it moves at the same speed as the oceans, the air, and our bodies. If the planet were to stop moving in an instant, the force released would be beyond anything we can imagine. The crust, which is the outer layer of the planet, would not remain calm. It would shift and tear apart violently, creating massive earthquakes and volcanic eruptions all over the world. At the same time, earthquakes happen today because the planet's outer shell is broken into large sections called tectonic plates. These plates float on top of molten rock. Deep, they move slowly over time, usually just a few centimeters each year. When they press against each other, stress builds up. When that stress releases, it causes an earthquake. Most earthquakes are small, and even the largest ones are limited to a single region. If Earth stopped moving suddenly, every tectonic plate on the planet would be forced to lurch at once. This would release energy on a scale far beyond any recorded earthquake in history. Imagine holding a rug on a smooth floor and yanking it hard. Everything on top slides and crashes into each other. Now, think of the planet's crust as that rug. The instant the planet stops, the crust would try to keep moving because of inertia. It would tear apart as it slid and cracked. Entire continents would shift by several meters in seconds. Mountain ranges would rise or collapse. Valleys would rip open, creating new canyons and massive gaps in the surface. These movements would not happen in a single place, but everywhere at once. The shaking would be so intense that no building or bridge could withstand it. Cities would crumble into rubble almost instantly. Roads would split open and railways would twist into tangled metal. Even solid bedrock would fracture and grind into pieces. People standing on the surface would not only be thrown off their feet, but also swallowed by collapsing ground. Large sections of land could vanish under sudden landslides or sinkholes. The energy released would make the most powerful recorded earthquakes seem tiny. The 1960 Valdivia earthquake in Chile, the largest in modern history, had a magnitude of 9.5. It caused entire coastlines to drop by several meters and sent tsunamis racing across the Pacific Ocean. If Earth stopped suddenly, the magnitude of these global quakes would go far beyond 10, possibly reaching levels we cannot measure. Waves of shaking would travel around the planet repeatedly, breaking apart the crust with each pass. The violent movement of the plates would also unleash volcanic eruptions. Volcanoes form when molten rock, called magma, pushes through cracks in the crust. Normally, this happens in specific regions, like the Ring of Fire around the Pacific Ocean. With every plate shifting at once, magma would find countless new paths to the surface. Dormant volcanoes would erupt without warning, while new ones would form in places that never had them before. Lava would pour across the land in massive flows, burning forests, cities, and farmland in its path. Along with lava, these eruptions would release ash and gases into the atmosphere. Volcanic ash is sharp and heavy, capable of collapsing roofs and destroying engines. In normal eruptions, it can cover entire towns. In this scenario, ash clouds would rise from thousands of eruption points across the planet at the same time. The sky would darken as sunlight struggled to break through. The air would become difficult to breathe, filled with sulfur and fine particles. Planes would not be able to fly through the choking clouds, and ships would lose sight of the horizon as ash blanketed the oceans. The sound alone would be terrifying. Earthquakes produce deep, rumbling noises as the ground cracks and grinds. Volcanoes roar as gas escapes from vents and lava explodes into the air. With every continent shaking and erupting at once, the combined noise would be deafening. It would be like standing next to thousands of jet engines, only much louder and lower in pitch. Even underground in bunkers or caves, the sound would vibrate through the rock and into human bodies. To understand the scale, picture a single volcano like Mount St. Helens, which erupted in 1980. That eruption flattened forests over 600 square kilometers and sent ash across several states. Now multiply that by thousands of volcanoes erupting at once, with earthquakes splitting the land beneath them. Entire regions would vanish under layers of lava and debris. Oceans would boil near undersea eruptions, releasing clouds of steam that would rise into the atmosphere. The crust would not settle quickly. After the first massive quakes, aftershocks would continue for days or even weeks. These smaller quakes, still stronger than any modern earthquake, would keep shaking what remained of the surface. Buildings already weakened would collapse completely. Cliffs and mountains would keep crumbling. Roads and rivers would shift again and again, making survival almost impossible. The sudden movement of land would also trigger huge tsunamis. When sections of the ocean floor rise or fall, they push massive amounts of water upward or downward. These waves would race across the oceans at hundreds of kilometers per h. Our coastal cities would be erased by walls of water taller than any skyscraper. Even places far inland would not be safe as rivers backed up and overflowed with the sudden surge. All these effects would interact, making the destruction worse. Ash clouds would block sunlight, causing temperatures to drop. Darkness would cover much of the planet. Crops would die without light, and animals would struggle to find food. People who somehow survived the earthquakes and eruptions would face hunger, cold, and disease. The planet's shape would even change. Earth is slightly flattened at the poles because it spins. If it stops suddenly, that shape would begin to even out. Water from the oceans would flow toward the poles, flooding new areas and exposing old coastlines. This shift in mass would cause more quakes as the crust adjusted. Volcanoes would keep erupting as new pressure built below the surface. The motion of the molten core deep inside the planet would also be affected. This core helps generate Earth's magnetic field. If the crust stopped while the core kept moving, the field could weaken or vanish. Without it, radiation from the sun would reach the surface directly, making survival even harder. Every living thing on Earth depends on the stability of the ground beneath it. When the ground itself becomes unstable everywhere at once, there is no safe place to hide. Earthquakes destroy not just buildings, but also the very land people depend on. Volcanoes cover fertile soil with lava and ash, making it impossible to grow food. Together, they create a chain reaction of destruction that would change the planet forever. To imagine it, think of a snow globe filled with tiny houses and trees. When you shake it gently, the objects move around but stay mostly in place. If you slammed it against a table, everything inside would scatter violently, breaking apart. The sudden stop of the Earth would be like that slam, except on a scale so large that even mountains and oceans would behave like fragile toys. Earth moves through space at an incredible speed, about 30 kilometers per second, or roughly 67,000 miles per h-hour. Everything on the planet moves at that same speed, including the atmosphere. We don't notice it because it all moves together, like passengers riding smoothly on a fast train. If the planet were to stop suddenly, the solid surface would halt, but the air would keep going at full speed. In an instant, the atmosphere would turn into a wall of moving air, creating winds so fast and powerful that they would shred almost everything on the surface of the planet. Right now, the fastest winds on Earth come from hurricanes and tornadoes. A strong hurricane might have winds of 250 kilometers per h-hour, and a tornado might reach around 480 kilometers per h-hour. These are already strong enough to tear apart buildings, uproot trees, and toss cars into the air. In the sudden stop scenario, the atmosphere would move thousands of times faster. At 30 kilometers per second, the wind would be more than 100,000 kilometers per h-hour. This is not just stronger than any storm, it is a force that would turn the entire sky into a weapon. Imagine standing outside during a gentle breeze. You feel the air push lightly against your skin. Now think about standing in front of a speeding train. The rush of wind would be so intense that you would be knocked over immediately. The sudden stop of Earth would be like every part of the sky turning into a train moving at unimaginable speed. The first blast would strip away everything not deeply anchored to the ground. Houses, cars, and even entire forests would lift off and be hurled across the landscape. Skyscrapers would snap like twigs. Bridges would tear apart as their supports gave way under the pressure. The oceans would not remain calm either. The moving atmosphere would drag massive amounts of water with it. Waves taller than mountains would form, racing inland at incredible speeds. These would not be like normal tsunamis, which are caused by underwater earthquakes. These waves would be driven by the sheer force of the wind, sweeping across entire continents. Coastal cities would vanish in moments. Even places far from the shore would face flooding as rivers surged out of their banks and lakes, exploded over their edges. The motion of the air would be strong enough to pull entire sections of ocean up into the atmosphere, turning water into airborne torrents. The surface of the land would be stripped bare. Soil, sand, and rock would grind into dust and join the storm. The wind would carry this debris at extreme speeds, turning the air into a sand-blasting machine. Anything left standing would be worn down and destroyed. Concrete buildings would crumble. Steel beams would bend and snap. Even mountains would erode as the surface layers were blasted away. Trees would be torn from their roots and shredded into splinters. Animals and humans would be lifted into the storm and ripped apart by the speed and debris. No shelter would be strong enough to survive the first minutes of this event. Air pressure would shift violently as well. Normally, the atmosphere presses down evenly on everything at about 14.7 pounds per square inch. In this scenario, that balance would be destroyed. Sudden changes in pressure would crush some structures and explode others. Windows would shatter instantly. Sealed containers like fuel tanks or water towers would burst as the outside pressure dropped or spiked. Even underground shelters would fail because the air rushing into tunnels and vents would act like a bomb, forcing its way through every opening. As the atmosphere kept moving, the friction between the air and the ground would generate enormous amounts of heat. This heat would ignite forests, grasslands, and cities. Fires would break out everywhere at once. The oxygen-rich wind would feed these flames, making them spread faster than any wildfire we know today. Smoke and ash would rise into the storm, mixing with dust and water to create choking clouds. Breathing would become impossible almost immediately. Anyone who somehow survived the initial blast would suffocate unless they found a sealed supply of clean air. The destruction would not stop after the first wave. The atmosphere would continue to move until friction slowed it down. During this time, the winds would circle the planet, hitting every region in turn. The storm would wrap around the globe, tearing apart everything in its path. There would be no calm center like in a hurricane. Instead, every place on Earth would be struck by a continuous, unbroken wall of moving air. The entire event might last for hours or even days, depending on how quickly the atmosphere lost speed. Consider how a storm surge works during a hurricane. The wind pushes water against the shore, creating waves that can sweep away homes and roads. Now imagine that happening at a scale far beyond any hurricane. The wind would not only push water, but also entire sections of the ocean floor, coral reefs, sandbars, and coastal cliffs would all be ripped away and carried inland. Fish, whales, and other sea life would be thrown across the land when the water finally settled. It would leave behind a landscape that looked completely different, with new lakes, rivers, and shorelines. Airplanes and satellites would not survive either. Planes in the sky would be ripped apart by the sudden changes in wind speed and direction. Pieces of wreckage would fall like rain. Satellites orbiting close to Earth would face extreme turbulence as the upper atmosphere shifted, causing many of them to burn up or crash. The loss of satellites would cut off communication, navigation, and weather tracking, leaving anyone alive completely isolated. The noise would be overwhelming. Wind at even 100 kilometers per HR can roar loudly enough to drown out voices. At thousands of kilometers per HR, the sound would be like a continuous explosion. The air itself would vibrate, producing deep, crushing tones that could rupture eardrums and cause physical pain. The storm would be so loud that no one could hear anything else, not even their own screams. The constant motion of the atmosphere would also affect the planet's temperature. The friction and heat generated by the winds would raise temperatures sharply. Fires would add more heat, creating a feedback loop that could scorch large areas. At the same time, ash and dust thrown into the sky would block sunlight, leading to sudden cooling once the initial heat faded. These rapid temperature changes would stress every living thing and make survival even harder. As the storm slowed, it would leave behind a world unrecognizable. The surface would be stripped of vegetation. Oceans would be lower in some places and higher in others, depending on where the water was dragged. The air would remain filled with dust, smoke, and toxic gases. Rain might fall, but it would be mixed with ash and chemicals. poisoning the ground without clean air, stable land, or safe water. Life would struggle to continue. The sudden stop of the planet would not just create a storm, it would turn the atmosphere into a force of destruction beyond anything seen on Earth. Winds moving faster than bullets would tear apart buildings, forests, and even the oceans themselves. The very air we depend on for life would become the most deadly threat imaginable, leaving nothing untouched as it circled the globe. The oceans cover more than 70% of the Earth's surface, and all that water moves with the planet as it travels through space. Right now, this movement is smooth and constant, so we don't feel it. The water stays in balance with the land beneath it, just as we do. If the planet stopped moving in an instant, the solid ground would halt, but the oceans would keep going at their original speed. This would create a chain reaction unlike anything humans have ever seen. The water would surge forward with unstoppable force, generating mega tsunamis that would flood entire continents. A normal tsunami forms when an underwater earthquake or landslide shifts part of the ocean floor. That sudden movement pushes water upward, creating a wave that spreads across the sea. Even the most destructive tsunamis recorded in history, like the one that struck Japan in 2011, or the Indian Ocean tsunami in 2004, were small compared to what would happen if Earth stopped suddenly. In those disasters, waves reached tens of meters in height and traveled at speeds of several hundred kilometers per HR. In the sudden stop scenario, the oceans would be moving at about 30 kilometers per second, which is over 100,000 kilometers per HR. The size and speed of the waves would be beyond anything we can measure. Imagine standing on a beach and seeing the tide suddenly rush out before a normal tsunami. In this case, there would be no warning. The ocean would lift and rise like a wall, thousands of feet high before crashing inland. Coastal cities would vanish instantly. Ports, harbors, and beaches would be gone in the first seconds. The force of the water would not just knock down buildings, but grind them into dust. Entire bridges would be torn away and swept miles inland. Ships, some larger than skyscrapers, would be carried far over the land before being shattered against hills or mountains. The destruction would not stop at the coastline. The volume of water would be so massive that it would push hundreds or even thousands of kilometers inland. Low-lying areas would disappear beneath a single moving body of water. Even highlands would not be safe as water climbed over them, like a fast-moving tide. Places far from any ocean, such as deserts and plains, would suddenly find themselves underwater. Rivers would reverse direction as the incoming surge overwhelmed them, flooding cities and towns that had never seen the ocean before. The motion of the water would also tear apart the ocean floor itself. As the surface of the Earth stopped, the seabed would lurch and crack. This would create underwater landslides and additional shifts in tectonic plates. Each of these events would generate its own tsunamis, adding to the chaos. Waves would crash into each other, combining their energy and creating even larger surges. Some waves might circle the globe multiple times, striking the same areas again and again. The water would not settle quickly. It would move back and forth for days or weeks before finally calming, leaving behind a planet reshaped by its power. Consider what happens when you slam your hand into a bowl of water. The water splashes upward and outward, spilling over the sides. Now imagine doing that with an entire ocean. The sudden stop of Earth would be like that on a global scale. The water would not just spill, it would explode across the land, carrying with it sand, rocks, and debris. The friction of this movement would grind coastlines into nothing. Coral reefs, beaches, and cliffs would all vanish beneath the force of the surge. The initial wave would carry everything in its path: buildings, vehicles, forests, and even the soil itself would be ripped away and mixed into the moving water. This debris would act like a weapon, smashing through anything that remained standing. A single tree carried by the surge could pierce through concrete walls. Entire neighborhoods would be broken apart and swept into the flood, leaving no trace of their original form. The weight of the water and debris combined would crush anything beneath it. Marine life would be caught up in the chaos. Whales, sharks, schools of fish, and all other ocean creatures would be swept inland along with the water. Many would die instantly from the force, while others would be stranded far from the sea when the water eventually receded. The balance of ecosystems would be destroyed in an instant, both in the ocean and on land. Coastal habitats like mangroves and wetlands would disappear entirely. The speed of the water would make survival impossible. A person caught in a normal tsunami has almost no chance to swim or escape. In this scenario, the waves would move at speeds far beyond that of a car, a train, or even a jet plane. There would be no time to run, no safe place to hide. Underground shelters would flood almost immediately. Even mountains would offer little safety as the water climbed their slopes and surged over their peaks. As the oceans moved, they would interact with the atmosphere. Winds generated by the shifting air would push the water even harder, creating churning waves on top of the main surge. Rain and spray would fill the air, reducing visibility to nothing. Lightning would flash above the storm as electrical charges built up in the clouds. The sound of the event would be overwhelming. The roar of the wind and water would drown out everything else, creating a constant, deafening noise. When the water reached its peak and began to flow back toward the ocean, the destruction would continue. The retreating surge would carry with it all the debris it had gathered, dragging it back across the land and into the sea. This back and forth motion would grind down whatever remained, reshaping coastlines and river systems. Entire continents would look different after the water finally settled. Some regions would be permanently submerged, while others would rise as land shifted beneath the weight of the oceans. The sheer mass of the moving water would also affect the planet itself. The redistribution of ocean weight would put new stress on tectonic plates. This could trigger additional earthquakes and volcanic eruptions long after the initial stop. Each new quake could create more localized tsunamis, adding layers of destruction to an already devastated world. The aftermath would be just as deadly as the initial surge. Salt water would cover farmland, poisoning the soil and making it impossible to grow crops. Freshwater supplies would be contaminated, leaving survivors without clean drinking water. Fish and other sea creatures rotting in the floodwaters would spread disease. Ash and smoke from volcanic eruptions would mix with the moisture, creating toxic rain that burned skin and plants. The planet's climate would change rapidly. Dust and debris thrown into the atmosphere would block sunlight, causing temperatures to drop. At the same time, the movement of the oceans would alter currents that regulate weather patterns. Some regions might face extreme cold, while others would suffer intense heat. Storms would become unpredictable and violent as the atmosphere tried to adjust. The sudden stop of Earth would turn the oceans into forces of destruction on a scale beyond imagination. Instead of gentle tides and calm waves, the seas would rise up and move like living walls of water, swallowing entire continents. The motion of this water would reshape the surface of the planet and erase much of what came before, leaving behind a world forever changed by the unstoppable power of the oceans. The Moon orbits Earth because of gravity. It moves forward through space at just the right speed, so that as it tries to travel in a straight line, Earth's gravity pulls it inward. This balance creates a stable path, much like a ball on a string being swung around in a circle. If Earth were to stop moving suddenly, that balance would break in an instant. It would continue moving at its original speed, and that would have dramatic and dangerous effects for both the Moon and the planet. Right now, Earth moves through space at about 30 kilometers per second, which is roughly 67,000 miles per hour. The Moon travels with Earth as part of this shared motion. If Earth came to a sudden halt, the Moon would still be moving forward. This would make it seem, from Earth's point of view, as if the Moon had been flung out of its orbit. In reality, the Moon would simply keep going while Earth's gravity tried to pull it back. What happens next would depend on the angle and speed of its motion at that moment. But none of the possible outcomes would be safe. One scenario is that the Moon could escape completely. If its forward motion was strong enough, it would overcome Earth's pull and break free. It would then move off into space, no longer bound to our planet. This would not happen slowly. The Moon would appear to drift away at first, but in only a short time, its distance would grow at a speed no spacecraft could match. From the surface, it would look like the Moon was rising higher and higher in the sky, then vanishing entirely. This loss would have enormous effects on Earth, even if no direct collision occurred. The Moon's gravity controls the tides. As it pulls on the oceans, water rises and falls in a predictable rhythm. Without the Moon, the tides would weaken drastically. Coastal ecosystems that depend on tidal changes would collapse. Animals like crabs, clams, and many fish species would lose their natural cycles. Human activities like fishing and shipping would face sudden challenges as currents changed unpredictably. The oceans would become unstable, and weather patterns that depend on ocean movement would shift in dangerous ways. The Moon also helps stabilize Earth's tilt. The planet does not spin perfectly upright. It tilts at about 23.5 degrees. This tilt creates the seasons. The Moon's steady pull keeps the tilt from shifting too much. If the Moon left, Earth's tilt could wobble wildly over time. Some areas might freeze while others burned, as sunlight patterns changed in unpredictable ways. Agriculture and ecosystems would suffer as growing seasons vanished or shifted to extremes. Another scenario is even worse. Instead of escaping, the Moon might fall toward Earth. This would happen if its path curved inward too sharply when Earth stopped. Gravity would pull it closer and closer, and its speed would increase as it fell. The final result would be a collision between the two bodies. The energy released by such an impact would be unimaginable. The Moon has a diameter of over 3,400 kilometers and a mass of more than 70 billion trillion kilograms. When something that massive strikes at orbital speed, the explosion would dwarf any natural disaster in history. The impact would melt rock and throw debris into space. Pieces of both Earth and the Moon would blast outward, forming a ring of molten material around the planet. Some of that debris might later come together to form a new moon, while other fragments would fall back to Earth as massive meteor strikes. The initial collision would create a crater larger than any continent, destroying everything on one side of the planet in a single moment. The shockwave would travel through the entire planet, triggering earthquakes, volcanic eruptions, and tsunamis everywhere at once. To imagine the scale, think of a large asteroid impact, like the one believed to have killed the dinosaurs 66 million years ago. That asteroid was only about 10 kilometers wide, yet it wiped out most life on Earth. The Moon is more than 300 times larger in diameter and millions of times more massive. The destruction would not just end many species, it would likely strip away the atmosphere and boil the oceans. Earth might become unrecognizable, a barren world of molten rock. Even before a collision, the Moon moving closer would cause serious problems. Its gravitational pull would increase dramatically as the distance shrank. Tides would rise far higher than normal, creating global flooding long before the impact. Coastal cities and entire islands would disappear beneath the water. The constant stress on the planet's crust would cause massive earthquakes and volcanic eruptions. The ground would twist and break as the moon's gravity tried to tear the surface apart. The moon itself would suffer as well. Earth's gravity would stretch it, creating cracks and fissures. Molten rock inside the moon might erupt through its surface, turning it into a glowing volcanic body. Pieces of the moon could break off and fall toward Earth, striking the surface like giant meteors. Each fragment would cause destruction similar to a modern asteroid impact, spreading fire and debris across huge areas. If the moon escaped instead of colliding, there would still be long-term effects. Without the moon's steadying influence, Earth's rotation might change over time. The length of a day could shift, either speeding up or slowing down. This would affect every aspect of life, from the growth of plants to human sleep cycles. Animals that rely on regular light patterns for hunting or migration would struggle to survive. Weather systems would grow unstable without the balance provided by predictable tides and a steady tilt. The psychological impact would also be profound. For thousands of years, humans have looked to the moon for guidance. It has been used to mark time, guide travel, and inspire myths and art. Its sudden disappearance, or its looming approach, would terrify people everywhere. In ancient times, a blood, red, or broken moon was seen as a sign of disaster. In this case, the disaster would be real and far beyond anything those early observers could imagine. The interaction between Earth and the moon depends on precise balance. The sudden stop of Earth would shatter that balance instantly. If you spin a ball on a string and then let go, the ball flies off in a straight line. If you pull too hard, the string snaps and the ball crashes into your hand. The moon would behave much like that ball. It might fly off into space, leaving Earth vulnerable and unstable, or it might be pulled in, slamming into the planet with catastrophic force. Either way, the result would reshape the planet forever. The oceans, the land, the atmosphere, and all life would face changes too vast to fully predict. Whether the moon escaped into the dark of space or came crashing down, the sudden stop of Earth would turn our closest neighbor in the sky into either a lost companion or a deadly threat. Earth stays in orbit around the Sunday because of a perfect balance between speed and gravity. The planet moves forward at about 30 kilometers per s-econd, which is roughly 67,000 miles per h-hour. At the same time, the Sunday's gravity pulls it inward. These two forces keep Earth moving in a curved path, rather than falling straight into the Sunday. If Earth stopped moving suddenly, that balance would break. The planet would no longer have the forward motion needed to resist the Sunday's pull, and it would begin to fall directly toward the center of the solar system. Imagine swinging a ball on a string. As long as the ball keeps moving, it stays out and away from your hand. If you let go of the string, the ball flies off in a straight line. If you stop swinging entirely, the ball drops straight down. Earth works the same way. Its forward speed is like the swinging motion. The Sunday's gravity is like the pull downward. If Earth's motion stopped, only the Sunday's gravity would remain, and Earth would plunge inward. At first, this fall might seem slow from our point of view. Earth is currently about 93 million miles from the Sunday. The initial movement would not be noticeable to someone standing on the surface. Over hours and days, though, the speed would increase as the Sunday's gravity pulled harder. Just like a dropped object falling faster as it nears the ground, Earth's fall would accelerate. Within a short time, the planet would be moving faster than it ever did in its stable orbit. The effects on Earth would begin almost immediately. As the planet started to fall inward, the extra pull from the Sunday would subtly stretch and squeeze it. The side facing the Sunday would feel a stronger force than the far side. This difference, called tidal stress, would grow as Earth got closer. At first, it might only cause minor shifts in the crust, like small earthquakes or unusual tides. As the pull increased, These stresses would tear the planet's surface apart. Entire regions would fracture, releasing magma and triggering volcanic eruptions on a massive scale. The oceans would respond dramatically as well. The Sunday's gravity would drag them toward its center. Water would pile up on the side of Earth facing the Sunday, creating colossal tides far larger than anything we have today. These tides would move constantly, drowning coastlines and flooding far inland. As the fall continued, the oceans would churn violently, adding tsunamis and storm surges to the destruction. Entire seas might even shift position as gravity reshaped the planet. During the first few days of the fall, life might continue as normal in some places, though weather would grow unstable. As Earth drew closer to the Sunday, the increase in heat would become impossible to ignore. Temperatures would rise steadily. Regions near the equator would heat first, turning deserts into furnaces and boiling shallow lakes. Within weeks, heat would spread to higher latitudes. Crops would wither, forests would dry out and ignite, creating massive wildfires that would spread without control. Animals and humans alike would struggle to find water or shelter. The atmosphere would begin to change as well. Rising temperatures would cause oceans and lakes to evaporate at an accelerating rate. The added water vapor would trap more heat, making the problem worse. Clouds would thicken, creating intense storms and constant lightning. Rainfall would come in violent bursts, flooding some regions even as others suffered drought. Winds would grow stronger as the difference between hot and cooler areas increased. Eventually, the entire atmosphere would become unstable with hurricane, force winds sweeping across continents. As Earth drew even closer, sunlight would grow dangerously intense. Right now, the amount of sunlight reaching the planet supports life by providing warmth and energy. When the distance decreased, the energy received would increase far beyond safe levels. Temperatures would climb high enough to melt asphalt, concrete, and even metal. People outside would suffer burns within seconds. Rivers would boil, and oceans would start to steam like giant kettles. The land would crack as moisture escaped into the air, leaving behind dry, barren ground. The final stages of the fall would be the most violent. As the Sunday's pull grew stronger, Earth's speed toward it would skyrocket. The planet would stretch under the strain, similar to how the moon causes tides, but on a much greater scale. Mountains would crumble as the crust tore apart. Volcanoes would erupt worldwide, sending ash and lava into the sky. The atmosphere itself might ignite as gases broke down under extreme heat and radiation. Breathing would become impossible as oxygen levels plummeted, and toxic fumes filled the air. From space, Earth would begin to look different. Clouds would disappear as water boiled away completely. The blue of the oceans would fade to dull brown and grey as they evaporated. Bright streaks of molten rock would glow where volcanic activity ripped through the surface. The planet would look more like Mercury or Venus, scorched and lifeless. Any remaining signs of civilization, cities, roads, and farms would be erased in fire and flood. As the planet approached the Sunday, the energy would reach levels capable of melting rock outright. At this point, no solid land would remain. The surface would turn into a sea of molten material, even deep underground. The intense heat would melt everything. The core of the planet, already molten iron and nickel, would become unstable. Pressure would build inside as the outer layers collapsed inward, releasing more heat and energy. Eventually, Earth might begin to break apart entirely. The tidal forces near the Sunday are so extreme that they can tear apart smaller objects like comets. If Earth came close enough, it too would be ripped into pieces. These fragments would spread out, some crashing into the Sunday, others scattering through space. If it stayed intact until the very end, the entire planet would plunge into the Sunday's outer layers, vaporizing completely in a burst of energy. To understand the speed of this fall, think about dropping a ball. When it first leaves your hand, it moves slowly. By the time it hits the ground, it moves much faster. The same principle applies here, except on a massive scale. As Earth drew closer to the Sunday, its speed would increase to tens or even hundreds of kilometers per second. The final moments before impact would happen so quickly that no event on the surface could keep up. From the ground, the Sunday would grow larger and larger in the sky until it filled much of the horizon. The heat and light would be blinding, making it impossible. People might imagine this process taking years, but in reality, it would happen much faster. The exact time would depend on the starting speed and distance, but it would likely take only a few months or even weeks for Earth to fall completely into the Sunday. During that short span, life on the surface would go through every stage of destruction, floods, storms, fires, and finally spacecraft and satellites would fail early in the process. As the planet fell inward, the increased radiation and gravity would disrupt their orbits. Many would crash into Earth or burn up in the atmosphere. Communication with other planets or space stations would end as systems broke down. Humans would have no way to track the fall or escape it. The loss of orbital motion would remove the single factor that protects Earth from the Sunday's constant pull. Without that balance, gravity would take over completely, drawing the planet inward with relentless force. From a stable home for life, Earth would become a falling object, plunging toward a star that would consume it entirely. Earth stays in its orbit around the Sunday because its forward speed balances the Sunday's gravity. The planet moves fast enough that instead of falling straight into the Sunday, it keeps curving around it. This creates a stable path that has lasted for billions of years. If that forward speed suddenly disappeared, the balance would break. Earth would no longer move sideways. It would begin to fall inward toward the Sunday. This fall would not be instant. It would follow a spiraling path, drawing closer and closer each day until the planet finally reached the Sunday after about 65 days. At first, the change would be almost invisible to people on the surface. Earth is about 93 million miles from the Sunday. That distance is so vast that the early stages of the fall would, for the first day or two, the Sunday might only appear slightly larger in the sky. People might not even notice right away. But beneath that calm appearance, the planet would already be accelerating. Gravity would pull Earth harder and harder as it drew closer. Just like a ball, falling faster as it nears the ground. Each hour, the speed would increase, and the distance between Earth and the Sunday would shrink more quickly. Imagine standing at the edge of a deep well and dropping a stone. At first, it moves gently, but as it falls, it speeds up, rushing faster and faster until it hits the bottom. Earth's path would work the same way, except on a cosmic scale. The planet's initial motion would form a slow inward spiral, but within a few weeks, the spiral would tighten, and the motion would become a rapid plunge. By the final days, Earth would be hurtling toward the Sunday at a speed so great that no spacecraft or technology could keep up. The first major sign for life on Earth would be subtle changes in the climate. As Earth moved closer to the Sunday, sunlight would grow more intense. Temperatures would begin to rise, first by just a few degrees, then by much more. Places near the equator would feel the effects earliest. Deserts would grow hotter, lakes would dry up, and crops would begin to fail. Animals and people would seek shade and water, but both would become harder to find. Within a week or two, the heat would spread across the entire planet. Polar ice caps would start to melt rapidly, adding huge amounts of water to the oceans. Coastal areas would flood as sea levels rose, even before the pull of the Sunday began to create massive tides. The spiraling motion would also affect Earth's rotation and the tides. As the planet fell inward, the Sunday's gravity would pull harder on the side facing it than on the far side. This difference, called tidal stress, would grow stronger each day. At first, it might cause slightly higher tides and minor earthquakes. As Earth got closer, the effects would become violent. Ocean tides would rise hundreds of feet, flooding cities and washing away entire regions. Earthquakes would grow in strength, splitting the ground and toppling buildings worldwide. Volcanoes would erupt as molten rock surged toward the surface through cracks created by the shifting crust. By the halfway point of the journey, the changes would be catastrophic. The Sunday would appear far larger in the sky, blazing with light so intense that looking directly at it would blind anyone instantly. The heat would climb past anything humans or animals could survive. Asphalt would melt on roads. Metal would become too hot to touch. Forests and grasslands would burst into flames spontaneously. The air would shimmer as moisture boiled out of the soil and water sources. Oceans would begin to steam, sending massive clouds of vapor into the atmosphere. These clouds would trap even more heat, creating a runaway effect that would cook the surface of the planet. Storms would become constant and violent. As the atmosphere filled with water vapor and heat, winds would grow stronger than any hurricane ever recorded. Rain would fall in sheets so heavy that it would seem like entire oceans were pouring from the sky. Lightning would strike continuously, igniting fires that would spread across continents. In some places, rain would turn to boiling water as it fell, scalding everything it touched. Breathing would grow difficult as the air became thick with steam, smoke, and ash. The spiral path toward the Sunday would not be smooth. As Earth moved closer, the gravitational pull would create uneven stresses on the planet. These stresses would cause sudden jerks in the orbit, like a roller coaster dropping without warning. Each of these shifts would trigger new waves of earthquakes and volcanic eruptions. Entire mountain ranges might collapse. New islands could rise from the sea as molten rock forced its way upward. The surface of Earth would constantly change, with landscapes destroyed and remade in hours. In the final weeks, the speed of Earth's fall would increase dramatically. The planet would race through space faster than ever before. From the surface, the Sunday would seem to swell with terrifying speed, filling more and more of the sky each day. The heat would reach levels that oceans would completely boil away, leaving empty basins where sea creatures once lived. Rivers would disappear. The ground itself would begin to melt. Molten rock would flow openly across the land, creating glowing rivers of lava that stretched for miles. Any remaining signs of life would be destroyed by fire, heat, or lack of breathable air. The atmosphere would break down under these extreme conditions. Gases would escape into space or burn away in chemical reactions driven by the intense heat and radiation. The sky would darken with ash and debris, then brighten again as flames consumed everything. Winds would scream at supersonic speeds, shredding whatever structures remained. Even deep underground shelters would offer no protection. The pressure and temperature would be too extreme for any technology to withstand. In the last few days, the spiral would tighten sharply. Earth would no longer circle slowly inward, but plunge almost directly toward the Sunday. The speed would be so great that the final distance would vanish in hours. Gravity would stretch the planet into an oval shape, pulling harder on the side closest to the Sunday. This stretching would rip apart the crust and mantle, exposing the molten core. Entire sections of Earth might break off, flying into space as fragments before the final impact. From space, Earth would no longer look like the familiar blue and green world. It would glow red and orange from heat, covered in active volcanoes and vast fields of molten rock. Plumes of gas and ash would rise high above the surface. Clouds would vanish completely as the last of the water boiled away. The planet would look more like a dying star than a home for life. When the final moment came, Earth would strike the outer layers of the Sunday with unimaginable force. If it held together, it would plunge directly into the Sunday's surface and vaporize almost instantly. If it broke apart earlier, the fragments would scatter across the Sunday's surface like meteors, each creating explosions larger than anything seen on Earth. From a distance, this would appear as a sudden bright flare on the Sunday, a sign that a planet had been consumed. The entire journey would last about 65 days. In that short time, the stable world we know would move through every stage of destruction. It would begin with slight changes in the tides and weather, then shift to global floods, storms, and fires. By the final weeks, the planet would be unrecognizable. The steady spiral inward would end in total annihilation as Earth vanished into the star that gave it life. Earth stays at a distance from the Sunday, where the heat and light are just right to support life. This balance has allowed oceans to stay liquid, plants to grow, and animals and humans to survive. If Earth began to move closer to the Sunday, this balance would vanish. Even a small decrease in distance would have major effects. The Sunday would appear larger and brighter in the sky, and the extra heat would start to change. Over time, the surface would grow so hot that it would become impossible for life to survive. At first, the changes might seem subtle. Temperatures would rise only a few degrees, similar to a very hot summer. Snow in cold regions would melt earlier in the year, and ice at the poles would begin to shrink. People might treat this as unusual weather, rather than a sign of disaster. But each day, as Earth moved closer, the Sunday's energy would grow stronger. The increase would not be gradual. The heat would climb faster and faster, much like standing near a fire and taking a step closer every few seconds. What feels warm at first would quickly become unbearable. Within days, the extra heat would cause global weather patterns to shift. Storms would grow large, hurricanes would form outside their normal seasons and regions. Winds would pick up strength as hot air rose and cooler air rushed in to replace it. Rain would fall in violent bursts, flooding some areas while others dried out completely. Crops would begin to fail as drought struck farmland and unexpected floods destroyed fields. Food supplies would grow uncertain and people would start to compete for resources. As the Sunday's apparent size in the sky increased, the difference would become clear to anyone looking up. At our current distance, the Sunday appears about half a degree wide, roughly the size of a coin held at arm's length. Moving closer would make it seem much larger, like a growing, blinding disk overhead. The light would be so intense that looking at it directly would damage eyes instantly. Even indirect sunlight reflecting off surfaces would be painful and dangerous. Shadows would grow sharp and dark as the sunlight became harsher. The extra heat would cause the polar ice caps to melt at a rapid pace. Glaciers that took thousands of years to form would vanish in weeks. The meltwater would pour into the oceans, raising sea levels worldwide. Low-lying cities and entire islands would disappear beneath the rising water. Coastal communities would face constant flooding, forcing millions of people to flee inland. As the oceans expanded from the heat, the flooding would accelerate, swallowing farmland and forests. Freshwater systems would also collapse as saltwater invaded rivers and groundwater supplies. With more heat, the oceans would release even greater amounts of water vapor into the atmosphere. Water vapor traps heat, creating a feedback loop that makes warming happen even faster. This would turn Earth's climate unstable. Storms would grow so large they could cover entire continents. Constant lightning would strike across wide regions, igniting fires in forests and grasslands. Rainfall would become chaotic, shifting between torrential downpours and complete drought. The predictability that life depends on would disappear. As temperatures climbed, everyday life would become impossible. Roads and sidewalks would grow soft as asphalt melted. Power lines would sag and fail as metal expanded in the heat. Vehicles would overheat quickly and engines would fail. People working outdoors would face deadly conditions. Even short exposure could cause burns, heat stroke, or death. Buildings would trap heat, making them unsafe to stay inside without constant cooling. Air conditioners would run non-stop, straining power grids until they collapsed under the demand. Plants would suffer first. Most crops can only grow within a narrow temperature range. Once the heat passed that limit, fields of wheat, corn, rice, and other staples would wither and die. Without plants, herbivores would starve, followed by predators that rely on them for food. Entire ecosystems would collapse in a chain reaction. Humans would face famine as food supplies dwindled. Fisheries would also fail as warming oceans drove fish to extinction. Coral reefs, already sensitive to heat, would bleach and crumble almost immediately. As Earth moved even closer, bodies of water would begin to boil. Shallow lakes and ponds would disappear first, followed by deeper lakes and parts of the oceans. Steam would rise into the atmosphere, creating thick clouds. These clouds would trap even more heat, creating a runaway greenhouse effect. The sky would darken with moisture, ash, and smoke from widespread wildfires. Rain would become acidic as it mixed with chemicals released by burning cities and forests. Breathing the air would become dangerous, and visibility would drop to almost nothing. The ground would also change under the relentless heat. Soil would dry out and crack, releasing stored carbon into the atmosphere. Forest floors would turn to dust, and deserts would expand rapidly, covering once fertile regions. Roads and runways would buckle and break. Rail tracks would twist as the metal warped. Buildings would collapse as foundations weakened. Underground systems like sewers and subways would flood with boiling water or steam, making cities unlivable. By this stage, the Sunday would dominate the sky. It would appear several times larger than normal, filling much of the horizon. The light would be so intense that even the deepest shade would not offer protection. Temperatures would rise high enough to melt metals and soften rock. Rivers would no longer flow. They would vanish entirely as water evaporated faster than it could collect. The few remaining oceans would shrink into isolated, steaming basins. The air would grow thick and heavy, filled with humidity and toxic gases. Animals and humans would be forced to retreat to whatever underground shelters they could find. Even then, the heat would penetrate deep into the ground, making survival difficult. Water supplies would boil away or become contaminated. Food would rot quickly in the oppressive heat. Electrical systems would fail one by one as components overheated. Communication would break down as satellites stopped working. Their circuits fried by the intense sunlight and heat radiating from the planet. The final stages would come quickly. With the Sunday so close, the amount of energy hitting Earth would rise far beyond anything life could endure. The surface would begin to melt. Lava would flow freely across continents, not from volcanoes, but from the crust itself, breaking down under the heat. Without an atmosphere, there would be no shield from the Sunday's radiation. The surface would bake directly under unfiltered sunlight. From space, Earth would no longer look like a blue and green world. It would glow red and orange as the oceans boiled away, and the land turned molten. Massive plumes of gas would rise into space, carrying the last traces of water and atmosphere. The planet would resemble Venus, but hotter and more violent. Any remaining structures would vanish beneath the molten flow, erased in seconds. Throughout this process, the Sunday would appear larger and more threatening. What started as a familiar disk in the sky would grow until it filled much of the view. The light would become blinding and constant, with no relief from clouds or nightfall. The heat would be so intense that even metal objects in shadow would be dangerously hot to touch. Day and night would lose meaning as the entire surface of Earth was bathed in relentless radiation. As the Sunday's size and heat grew, Earth's habitability would vanish step by step. At first, only certain regions would be affected. Eventually, the entire planet would be engulfed. No land, ocean, or atmosphere would remain unchanged. Life would have no place to hide as the planet transformed into a scorching, lifeless sphere, spiraling closer to the star that once gave it warmth and light. Earth's oceans and atmosphere exist in a delicate balance that makes life possible. The oceans store heat, regulate temperatures, and feed the water cycle. The atmosphere traps just enough warmth to keep the surface comfortable while blocking dangerous radiation from space. If Earth moved closer to the Sunday, rising heat would begin to boil away the oceans, and the atmosphere itself would start to break apart and drift into space. In a short time, the planet would lose its water and air, leaving behind a dry, lifeless world. At first, the extra heat would only increase evaporation. Oceans would release more water vapor into the air, creating thicker clouds and heavier rainfall would grow intense and unpredictable. Some areas would flood constantly, while others would suffer deep droughts. As more water entered the atmosphere, global humidity would rise, making the air feel heavy and oppressive. This water vapor would trap even more heat, speeding up the warming process. What began as a gradual increase would quickly turn into a runaway effect, with each degree of warming causing faster and faster changes. Within days or weeks, shallow lakes and ponds would begin to dry out completely. Rivers would shrink as their sources evaporated. Large inland seas like the Caspian or the Great Lakes would recede, leaving cracked, barren land where water once flowed. Coastal areas would flood at first as melting ice raised sea levels, but soon the opposite would happen. As oceans boiled, the water would escape into the atmosphere instead of staying on the surface. Steam would rise constantly from the seas, turning the horizon into a white, hazy blur. The sky would change color as the atmosphere filled with vapor and heat. Clouds would grow thick and dark, blocking sunlight in some places while trapping it in others. Storms would rage across entire continents. Winds would reach hurricane strength, fueled by the extreme differences between hot and cooler regions. Rain would fall in torrents, only to evaporate again before it reached the ground in some areas. Lightning would strike constantly as the unstable atmosphere built up enormous electrical charges. These storms would not pass in a day or two, they would circle the planet endlessly, reshaping the land with floods and fires. As the heat continued to rise, the oceans would begin to boil in earnest. The surface water would reach the boiling point and release massive amounts of steam into the air. This would happen first near the equator, where sunlight is most direct, and then spread outward. Entire sections of ocean would turn to vapor almost overnight. The process would feed itself. As more water boiled away, the heat would intensify, causing even faster evaporation. Steam would climb high into the atmosphere, carrying salt and other particles with it. These particles would fall back to the surface in strange, toxic rains, poisoning the land and remaining water sources. The loss of liquid water would devastate life immediately. Marine animals would have no place to live as their habitats vanished. Coral reefs would crumble as the water level dropped and temperatures soared. Fish populations would collapse, followed by birds and mammals that depend on them. On land, animals would die from dehydration and heat stress. Plants would wither and burn as soil dried out and temperatures exceeded their limits for survival. Whole ecosystems would collapse in a matter of weeks, leaving behind only barren ground and dead vegetation. As the oceans disappeared, the atmosphere itself would begin to change in dangerous ways. Without the cooling effect of water, the surface would grow hotter each day. The remaining moisture in the air would rise higher and higher, eventually reaching altitudes where solar radiation would break the molecules apart. Water vapor would split into hydrogen and oxygen under the intense ultraviolet light from the sunday. The lighter hydrogen would escape into space, never to return. The heavier oxygen would either combine with other elements or react violently, fueling massive fires on the surface. The escape of hydrogen would be irreversible. Over time, this slow leak would remove nearly all water from the planet. Even if some areas still had lakes or underground reserves, the loss of hydrogen would prevent new water from forming. Earth would dry out completely, just as Mars did billions of years ago. The surface would be left covered in salt flats, cracked mud, and vast expanses of desert. Any remaining signs of the former oceans would exist only as scars on the landscape. As water left the atmosphere, the air itself would thin. Oxygen and nitrogen molecules would also begin to break apart under the growing heat and radiation. Some would escape into space, while others would react with the surface in chemical processes driven by extreme temperatures. The protective shield of air around Earth would weaken, letting in more harmful radiation from the sunday. With no atmosphere to block it, the surface would be bombarded by ultraviolet light and cosmic rays. These forces would sterilize the planet, destroying any remaining life down to the microscopic level. The sky would grow darker as the atmosphere thinned. At first, it might appear strange but still familiar, with clouds and storms forming in odd patterns. As the air continued to escape, the blue color would fade. Without scattered sunlight, the sky would turn black even during the day. Much like the view from the moon, the sunday would shine fiercely in this dark sky, its light harsh and unfiltered. Stars would become visible at all times, a constant reminder of space pressing down on the planet. Temperatures on the surface would climb to unimaginable levels. Without an atmosphere to spread heat around, the side facing the sunday would grow blisteringly hot, while the opposite side froze in darkness. Rocks would crack and melt under the intense heat. Metal would soften and warp. Any remaining structures built by humans would collapse as materials failed under these extreme conditions. Even underground shelters would not protect against the loss of air and the deep penetration of heat and radiation. Winds would reach terrifying speeds during the final stages. As the last gases fled into space, they would create violent currents, whipping across the surface with destructive force. These winds would strip away loose soil, sand, and debris, carrying it into space. The ground would be scoured clean, leaving behind exposed bedrock and molten plains. Mountains would erode quickly, not over millions of years, but in weeks or months, as the atmosphere ripped past at supersonic speeds from space. Earth would begin to resemble Venus or Mercury. The blue oceans and green continents would vanish, replaced by dull, scorched surfaces. Plumes of escaping gas would rise into the void, glowing faintly in the sunlight. The once thick atmosphere would shrink to a thin haze, barely visible around the planet. Over time, even that haze would disappear, leaving Earth completely exposed to space. The final stage would come when all water was gone and almost no air remained. With nothing left to protect the surface, the sunday's radiation would bake it directly. The land would glow faintly from heat, with molten rivers of rock winding through deep cracks. Without water, the planet's crust would grow brittle and unstable. Earthquakes would split the land apart, while volcanic eruptions vented the last gases from deep inside. Eventually, even those eruptions would stop as the planet's interior cooled and hardened. What remained would be a silent, airless world, with no oceans, no clouds, and no life. The surface would be marked by salt deposits, lava flows, and the ruins of what once thrived there. Earth would be nothing more than a scorched rock orbiting a star stripped bare by the very heat and light that once sustained it. As Earth spirals inward toward the Sunday, the pull of gravity grows stronger every moment. At first, this change would be slow, almost unnoticed by those on the surface. The Sunday would appear slightly larger each day, and temperatures would rise gradually. But as the distance closed, the acceleration would increase. The planet would move faster and faster, locked in a final fall toward its star. By the end of the journey, Earth would be racing through space at incredible speeds, unable to escape the Sunday's grip. In its last moments, the planet would be destroyed completely, torn apart by heat and gravity before vanishing into the blazing surface. In the early stages, Earth's orbit would shift smoothly. The Sunday's pull would draw it inward along a spiraling path. Each day, the heat would grow stronger, creating storms, floods, and wildfires across the surface. As oceans boiled and the atmosphere thinned, life would vanish in waves of extinction. By the time Earth reached the inner part of its spiral, no plants, animals, or humans would remain. The planet would already be a scorched, barren world, stripped of water and air, its surface cracked and glowing with molten rock. As the distance shrank further, gravity would begin to tear at the planet itself. This effect, called tidal force, happens when one side of an object feels a stronger gravitational pull than the other. We see a mild version of this every day in the form of ocean tides caused by the moon. Near the Sunday, this same force would be far more violent. The side of Earth facing the Sunday would be pulled much harder than the far side, stretching the entire planet. Cracks would spread across the crust like fractures in glass. Mountains would collapse, and molten rock would pour out of deep fissures. Even the core would feel the strain, as layers of the planet shifted and tore apart under the relentless pull. As Earth moved closer, these tidal forces would increase beyond anything the planet could withstand. Whole sections of crust would lift into the sky, breaking free of gravity and drifting into space before falling back in fiery fragments. The surface would no longer resemble continents or oceans. Instead, it would be a shifting landscape of lava flows, deep rifts, and erupting volcanoes. From space, Earth would glow red and orange like a dying ember. The once blue planet would become a sphere of fire and molten rock surrounded by plumes of escaping gas. At the same time, the Sunday's heat would grow overwhelming. Even before impact, the intensity of sunlight would be enough to melt solid rock. Metals would soften and flow like wax. The thin remains of the atmosphere would ignite, creating a burning halo around the planet. Any gases still clinging to the surface would be stripped away by solar radiation and swept into space. Without an atmosphere, there would be no protection from the Sunday's deadly ultraviolet rays and charged particles. The surface would bake under direct, unfiltered radiation, turning everything to ash and molten slag. As Earth approached the Sunday, the speed of its fall would become staggering. In the final hours, the planet would move tens of kilometers every second. This extreme velocity would add to the destruction. The forward motion would generate friction as the planet plowed through the Sunday's outer atmosphere called the corona. This friction would produce intense heat, far beyond anything on Earth today. The outer layers of the planet would vaporize instantly, forming a glowing trail of gas and dust. Earth would begin to look like a comet, its body shrinking as material burned away into space. The last moments would be violent and brief. If the planet reached the Sunday intact, it would strike the outer layer of the star with unimaginable energy. The impact would release more heat than every volcano, earthquake, and explosion in Earth's history combined. The Sunday's surface, made of superheated plasma, would tear apart the planet completely. Rock, metal, and molten core material would disintegrate, turning into gas in an instant. Some of this material would sink into the Sunday, mixing with its swirling currents. The rest would blast outward in massive solar flares and arcs of plasma, scattering remnants of Earth across the solar system. Another possibility is that Earth would not reach the Sunday in one piece. Long before impact, the tidal forces might rip it apart completely. The planet would split into fragments, each following its own path inward. These pieces would collide with one another, breaking down further into smaller chunks and clouds of dust. The Sunday's gravity would pull these fragments into long streams, wrapping them around the star like ribbons of glowing debris. As they fell, each fragment would vaporize on contact with the Sunday's outer layers, disappearing in bursts of light and heat. From a distance, this destruction would be dramatic. Observers on another planet or spacecraft would see the Sunday flare brighter as the falling material added energy to its surface. A massive eruption of solar plasma might shoot into space, carrying pieces of Earth with it. These fragments would cool and harden into meteoroids, some of which could strike other planets or moons in the solar system. In this way, tiny parts of Earth might continue to travel through space long after the planet itself was gone. The scale of the forces involved would be almost beyond understanding. The Sunday's gravity is so strong that even light struggles to escape it. As Earth approached, the difference in pull between its near and far sides would become extreme. The planet would stretch into an oval shape, like soft clay being pulled apart. In the final minutes, this stretching would rip the planet completely in two. The core would burst open, releasing molten iron and nickel into space. The fragments would then spiral inward like meteors, one by one consumed by the Sunday. The energy released as Earth vaporized would not affect the Sunday itself in any significant way. Compared to the mass of the star, Earth is tiny, less than a speck of dust. The Sunday would continue burning as if nothing had happened. The only sign would be a brief, bright flare visible to anyone watching from afar. For the star, the destruction of a planet would be a minor event, for everything that once lived on Earth before the final collision. The changes to Earth would already be complete. Oceans would have boiled away long before. The atmosphere would have escaped into space, leaving no air to breathe. The surface would have been scorched and cracked, reshaped by lava and fire. Any structures built by humans would have been erased, melted into unrecognizable forms, or buried under molten flows. By the time Earth reached the Sunday, it would no longer resemble a living planet at all. It would be nothing more than a glowing, broken sphere, ready to be consumed by forces far beyond its strength. As the planet crossed into the Sunday's outer layers, it would disappear almost instantly. The remaining fragments would mix with the star's plasma, becoming part of the Sunday itself. For a brief moment, the Sunday would shine slightly brighter, as if marking the event. Then it would return to its usual appearance, continuing to burn as it has for billions of years. Earth, once a vibrant world filled with life, would be reduced to scattered atoms, its entire history erased in a single, fiery moment. The moment Earth stopped moving, destruction would begin everywhere at once. The planet moves through space at about 30 kilometers per second, which is over 67,000 miles per h-hour. Everything on the surface, including the oceans and the atmosphere, moves with it. If the solid ground halted instantly, all that moving mass would keep going. The result would be a chain of events, so violent and fast that most life would be wiped out within hours to days. The first disaster would come from the air itself. The atmosphere would not stop with the ground. It would keep moving forward at orbital speed, creating winds unlike anything Earth has ever seen. The strongest hurricanes today have winds around 250 kilometers per h-hour. These new winds would be hundreds of times faster, reaching speeds of over 100,000 kilometers per h-hour at that speed. The air would act like a solid wall, slamming into everything in its path. Buildings, trees, vehicles, and animals would be ripped apart instantly. Whole cities would be flattened before anyone had time to react. Even mountains would begin to erode as the surface layers were sandblasted away by the rushing atmosphere. These winds would also pick up debris, turning it into deadly projectiles. Cars, boulders, and even pieces of skyscrapers would be hurled through the air at speeds far beyond that of bullets. The debris would destroy anything still standing after the first blast of wind. No shelter, no matter how deep or reinforced, could withstand the constant battering. Underground bunkers would flood with rushing air and collapse as the ground above them tore apart. The oceans would create another wave of destruction. Water would keep moving just like the atmosphere, surging forward with unstoppable force. The sudden shift would send massive walls of water racing across the planet. These would not be ordinary tsunamis. They would be mega tsunamis, taller than skyscrapers and moving at extreme speeds. Entire coastlines would be erased within moments. Ships, some as large as buildings, would be lifted high into the air before being smashed inland. The force of the water would strip away soil, forests, and even bedrock, leaving behind barren, scoured landscapes. As these waves spread inward, they would merge and crash into each other. Floods would reach far beyond normal coastlines, drowning valleys and plains, hundreds of miles from the ocean. Even the tallest mountains would not be safe, as the sheer volume of water climbed higher and higher. Towns far inland would be swallowed just as quickly as those near the sea. The retreating water would drag debris back with it, grinding everything into pieces and pulling it out to sea before the next wave struck. At the same time, the ground itself would respond violently. When the surface stopped, the molten layers beneath would keep moving. This difference would tear the crust apart, triggering global earthquakes. Unlike normal quakes that are limited to certain regions, these would strike everywhere at once. Entire continents would shake so violently that they would break apart. Skyscrapers and bridges would collapse before the first wave of shaking even ended. Roads and railways would twist into useless shapes. Deep fissures would open without warning, swallowing buildings and people whole. Volcanoes would erupt across the planet as magma forced its way to the surface through the cracks. Some volcanoes that had been dormant for thousands of years would explode without warning. Lava flows would pour across the land, burning forests and cities alike. Ash clouds would rise into the atmosphere, blocking out sunlight and making the air difficult to breathe. This ash would also mix with the rushing winds, turning the air into a scorching, abrasive storm that would strip flesh from bone. Heat would follow close behind. The friction from the rushing atmosphere and water would generate enormous amounts of thermal energy. Fires would break out everywhere at once. Grasslands, forests, and urban areas would ignite instantly. The winds would feed these fires, spreading them at unimaginable speed. Even areas that were not directly hit by flames would be baked by intense heat carried through the air. Temperatures would rise so quickly that animals and humans would suffer fatal burns in seconds. The combined effect of the winds, waves, quakes, and fires would create shock waves that traveled around the planet. These shock waves would slam into structures and living things with crushing force. Internal organs would rupture under the pressure. Buildings already damaged by wind and water would crumble completely. These waves would echo back and forth, striking the same regions repeatedly and leaving nothing standing. Within hours, most forms of life would be gone. Coastal regions would vanish first, swept away by the oceans and shredded by the winds. Inland regions would fall soon after. As earthquakes and fires spread, entire ecosystems would collapse instantly. Herds of animals would be wiped out. Forests would be flattened or burned to ash. Rivers and lakes would boil or drain away through massive cracks in the ground. Humans would have no chance to organize a response. Power grids and communication networks would fail almost immediately. Satellites in orbit would crash or burn up as the atmosphere surged violently. Planes would be torn apart mid-air. Cars and trains would be thrown like toys. Emergency services would disappear, along with the cities they served. Even if small groups of people survived the first minutes underground, they would face starvation, toxic air, and the complete collapse of every system that supports human life. The few hours after the event began would be marked by complete chaos. Darkness would spread as ash and smoke blocked out sunlight. The sky would glow red and orange from fires and molten rock. Winds would scream like jet engines. The ground would heave and crack beneath every step. Sounds of destruction would drown out everything else. The roar of the ocean, the rumble of quakes, the roar of flames, and the endless crash of debris. By the end of the first day, nearly every living creature on the surface would be gone. Some deep-sea creatures might survive for a short time in the depths. But the boiling of the oceans and the mixing of toxic chemicals would soon kill even them. Insects and small burrowing animals might cling to life in isolated pockets, but without food or stable conditions, they too would vanish within days. The few remaining humans, if any, would face a world unrecognizable. The air would be unbreathable, filled with smoke, ash, and poisonous gases from volcanic eruptions. Water would be contaminated with salt, debris, and toxins. The land would be covered in molten rock and layers of burned material. There would be no crops to harvest, no animals to hunt, and no safe shelter to hide in. The speed of the destruction would make survival nearly impossible. Most extinction events in Earth's history, like the asteroid that killed the dinosaurs, took place over months or years. This event would unfold in hours. The sudden stop of the planet's motion would unleash all forces at once, leaving no time for adaptation or escape. Within a single day, Earth would go from a living world filled with billions of species to a dead, burning shell. From space, the planet would look like a glowing ember, covered in streaks of fire and massive clouds of smoke. The blue oceans and green continents would vanish beneath a blanket of red and black. The atmosphere would swirl violently as it thinned, revealing flashes of molten land below. In a short time, even those signs of movement would fade as the fires burned out, and the surface cooled into a scorched wasteland. What remained would be silent, lifeless, and still, a world that had once been full of life erased almost in an instant. Every living thing on Earth depends on the food chain. At the very base are plants, which capture sunlight and turn it into energy through photosynthesis. Animals eat those plants, and other animals eat them in turn. This process supports everything from tiny insects to the largest whales. If plants fail, the entire system collapses. Without stable sunlight and a predictable climate, plants cannot survive, and once they die, every creature that depends on them begins to fall as well. This chain reaction would begin long before Earth even reached the Sunday in its final spiral. When Earth started to drift closer to the Sunday, the first changes would affect light and temperature. The Sunday would grow slightly larger in the sky, and the amount of energy reaching the surface would increase. At first, this might seem like nothing more than a particularly hot season. Farmers would notice crops sprouting earlier, snow melting sooner, and growing seasons shifting. These small changes might even seem beneficial in some regions, but the balance would quickly tip. The extra heat would cause weather patterns to grow unstable, and the once predictable cycle of sunlight and rainfall would become chaotic. Plants depend on steady conditions. Most species can survive drought or heat for a short time, but when both happen at once and on a global scale, their systems fail. As Earth moved inward, some areas would receive too much sunlight, burning plant leaves and drying the soil. Other areas would be buried under constant storms and flooding as evaporation from the oceans increased. In places where rain once fell gently, it would now come in violent bursts. washing away seeds and roots before they had a chance to grow. As temperatures rose, polar ice would melt and oceans would expand, flooding low-lying farmland. Saltwater intrusion would contaminate rivers and groundwater, poisoning crops that depend on fresh water. Farmers would try to adapt by moving to higher ground or planting heat-tolerant species. But the speed of change would overwhelm even the most advanced technology. Crops like wheat, rice, and corn, which provide most of the calories humans eat, have narrow temperature limits. Once those limits were crossed, they would wither and die no matter how much irrigation or fertilizer was used. The failure of plants would spread rapidly through natural ecosystems. In forests, trees would drop their leaves early and stop producing food. Grasses would dry out and turn to ash in the heat. Wetlands would vanish as water evaporated or boiled away. These environments are home to countless insects, birds, and mammals. Without plants, herbivores would lose their only source of energy. Herds of grazing animals like deer, elephants, and antelope would begin to starve within weeks. In the oceans, algae and phytoplankton would face the same problem. These microscopic plants form the base of the marine food chain. As ocean temperatures rose and acidity increased, they would die off in massive numbers. Coral reefs, which rely on these tiny organisms, would bleach and crumble, leaving fish without shelter or food. Once the herbivores began to die, predators would follow. Lions, wolves, sharks, and countless other carnivores rely on healthy populations of prey. Without them, they would starve. Some predators might turn on each other in a desperate attempt to survive, but that would only delay their collapse. Within months, most large animal species would vanish entirely. Smaller animals like rodents and insects might survive a little longer by eating stored food or scavenging, but even they would face limits. Without plant life to regenerate the ecosystem, there would be nothing left to replace what was consumed. Humans would face their own crisis at the same time. Global agriculture would fail as farmland dried out, flooded, or burned. Grain reserves might feed people for a short time, but demand would far outstrip supply. Cities would run out of food within days. Governments might attempt to ration supplies, but transportation systems would fail as fuel ran out and infrastructure crumbled under constant natural disasters. Starvation would spread quickly, especially in regions already vulnerable to drought or poverty. Conflicts over remaining resources would erupt, further speeding the breakdown of human societies. The oceans, once a major food source for billions of people, would no longer be reliable. As plankton died off, fish populations would crash. Fishermen would return to empty nets. Species that humans rely on, like tuna, salmon, and shrimp, would disappear. Even shellfish like clams and oysters would vanish as ocean chemistry changed. Coastal communities would be left without both food and protection, as rising seas and storm surges destroyed their homes. As more plants died, the atmosphere would begin to change. Plants play a crucial role in maintaining breathable air. They release oxygen and absorb carbon dioxide. Without them, oxygen levels would fall while carbon dioxide levels rose. This would make breathing harder for animals and humans. The extra carbon dioxide would also trap more heat, worsening the runaway greenhouse effect already underway. Fires would rage across dead forests and grasslands, releasing even more carbon into the air and further accelerating warming. The lack of plants would also destabilize the soil. Roots hold the ground together, preventing erosion. Without them, wind and water would carry away the topsoil, leaving behind barren rock and sand. Farmland would be stripped of nutrients, making it impossible to grow new crops, even if the climate somehow stabilized. Dust storms would sweep across continents, turning skies dark and choking the air. These storms would bury cities and block sunlight, creating even harsher conditions for any surviving life. Insects, which form an essential part of many ecosystems, would experience their own collapse. Pollinators like bees and butterflies depend on flowering plants. Without flowers, they would die off quickly. This would remove yet another link in the chain, preventing plants from reproducing even if conditions briefly improved. Other insects like mosquitoes and flies might survive longer by feeding on decaying matter, but they would spread disease in the absence of natural controls, like birds and bats. These outbreaks would further weaken remaining animal and human populations. Even deep underground and in the oceans, life would not escape the chain reaction. Some bacteria and extremophiles might cling to existence near volcanic vents or deep within the crust. But without energy from the surface, even these resilient forms would dwindle over time. Complex ecosystems built around these microorganisms would vanish as their food sources disappeared. The collapse would reach into every corner of the biosphere. For humans, the psychological effects would be devastating. As crops failed and forests turned to wastelands, entire cultures would face the loss of familiar landscapes. Sacred sites, fertile valleys, and beloved coastlines would vanish beneath floods or dust. The sense of stability that comes from the turning of seasons and the growth of plants would disappear. People would witness the end of the natural world they had always depended on, leaving them fearful and desperate. In the final weeks before Earth reached the Sunday, the planet would be almost unrecognizable. Once green forests would be reduced to blackened stumps. Farmlands would be cracked and dry, their soil blown away by relentless winds. Oceans would steam and shrink, their surfaces covered with floating mats of dead organisms. The air would smell of smoke, salt, and decay. With no plants left to anchor the system, the food chain would be completely broken. Predators would vanish first, followed by herbivores, then scavengers. Humans at the top of this chain would face starvation and disease, with no hope of rebuilding what had been lost. Even before the final collision with the Sunday, Earth would already be a dead world. The collapse of the food chain would ensure that life ended long before the planet itself was destroyed, leaving only a silent, empty shell spiraling toward its fiery end. The oceans cover more than 70% of Earth's surface and play a central role in regulating the planet's temperature and climate. They store heat, feed the water cycle, and provide a home for countless species. If Earth moved closer to the Sunday, the balance between heat and water would begin to fail. Rising temperatures would first warm the oceans, then bring them to a boil. Over time, they would completely evaporate, leaving behind a scorched crust and a planet stripped of its most vital resource. At the start, the change would seem small. The top layers of the oceans would heat faster than usual, like a pot of water sitting on a stove set to low heat. Sea ice at the poles would melt rapidly, adding more liquid water to the surface. Coastal regions would flood as melting ice raised sea levels. People might see this as extreme climate change, but still something they could adapt to. Fishing fleets would still sail, ports would still function, and life near the ocean would continue, even if storms became more frequent and violent. But as Earth kept moving inward, the Sunday's energy would increase far beyond what the oceans could handle. The water near the surface would no longer just warm. It would start to simmer, forming vast clouds of steam. These clouds would rise high into the atmosphere, carrying heat with them and trapping even more sunlight below. Rainfall would grow erratic and intense, falling in torrents before evaporating again almost instantly. Storms would grow massive and constant, fueled by the endless supply of heat and moisture. Hurricanes would no longer be seasonal events, they would be permanent features, circling the planet without rest. The evaporation would create a feedback loop. As more water entered the atmosphere, it would trap additional heat, which in turn would cause even faster evaporation. the oceans would lose their ability to cool the planet, and their temperature would rise steadily. Once the surface reached the boiling point, the process would accelerate. Vast sections of ocean would bubble and steam like giant kettles. From space, the surface would appear to writhe and churn as clouds of vapor rose in every direction. Marine life would suffer first. Fish and other creatures can only survive within narrow temperature ranges. Coral reefs would bleach and crumble. Shellfish would die as the water grew too warm and acidic. Plankton, the foundation of the ocean food chain, would disappear. As these small organisms died, the entire marine ecosystem would collapse. Whales, sharks, and other large animals would starve as their food sources vanished. Dead creatures would rise to the surface, creating floating mats of decay that would spread for miles before breaking apart in the violent waves. As boiling intensified, the destruction would reach the coastlines. Steam would roll over beaches and coastal cities, scalding anything it touched. Salt and other minerals dissolved in the water would be left behind as the liquid evaporated. These deposits would form jagged, crusty layers on the seafloor and along the shores. Areas once filled with crashing waves and sea spray would become fields of sharp, white salt and broken coral. The smell of salt and decay would fill the air, making breathing difficult even before the atmosphere turned toxic. Inland, the effects would spread through the water cycle. Rivers fed by the oceans would run dry as their sources evaporated. Lakes and wetlands would shrink, then vanish completely. Farmers and communities that relied on these waters would face immediate shortages. As rainfall patterns broke down, some regions would flood, while others turned to desert. Freshwater fish and plants would die, leaving behind empty riverbeds and cracked mudflats. Without rain, forests and grasslands would wither, and wildfires would sweep across the land unchecked. The atmosphere would grow thicker with water vapor as evaporation continued. This heavy, wet air would trap heat close to the surface, creating conditions similar to a greenhouse. Temperatures would rise even faster, pushing the oceans past the point of no return. Clouds would cover the planet almost completely, blocking direct sunlight but holding in vast amounts of heat. The surface would remain sweltering even at night, with no cooling period to offer relief. Eventually, the oceans would begin to disappear entirely. As boiling reached deeper layers, steam would erupt violently, shooting skyward in towering plumes. The sound would be deafening, like constant explosions echoing across the planet. Entire sections of ocean could rise as vapor in a matter of hours. The last marine life clinging to survival would be cooked instantly as the water temperature soared. The once teeming seas would become vast, empty basins of steaming liquid, their surfaces hidden beneath thick clouds of white vapor. As more water boiled away, the atmosphere would start to change. Ultraviolet radiation from the sunday would break apart water molecules high above the planet. The lighter hydrogen would escape into space, while the heavier oxygen would remain and react with other elements. This process would permanently reduce the amount of water on Earth. Even if temperatures dropped later, the lost hydrogen would never return, making it impossible for the oceans to reform. The retreating water would expose the ocean floor, revealing landscapes no human had ever seen. Deep trenches, ridges, and mountains, normally hidden under miles of water, would rise into view. These areas would not be peaceful, quiet places. As the pressure from the overlying water vanished, gases trapped in the seafloor would burst outward, adding toxic fumes to the already unstable atmosphere. Methane and sulfur compounds would escape in massive plumes, spreading across continents and poisoning what little life remained. The exposed seafloor would also begin to crack and collapse. The weight of the oceans helped stabilize the Earth's crust. Without it, tectonic plates would shift violently. Underwater volcanoes would erupt openly on the surface, sending lava and ash into the air. Earthquakes would tear through the newly revealed landscapes, breaking apart the brittle crust left behind by evaporated seas. The combination of volcanic activity and constant quakes would make the planet's surface unstable and dangerous. By this stage, the ocean basins would no longer hold liquid water. They would be dry, barren stretches covered in salt, sand, and fractured rock. The heat would bake these areas until they glowed faintly at night, like embers cooling after a fire. Winds would sweep across the dry basins, picking up salt and dust and carrying it into the atmosphere. These storms would scour the land and choke anything left alive. From space, the planet would appear brown and grey, with no trace of the blue oceans that once defined it. As the last water vanished, the atmosphere would thin. Steam would continue to rise, but with no liquid left to feed it. The clouds would break apart. The sky would darken as the remaining gases escaped into space. Without water to regulate temperature, the surface would swing between blistering heat and deep cold. The crust would crack under these extreme changes, releasing more gases and molten rock. The once stable system of Earth's surface and oceans would be gone forever. The disappearance of the oceans would also erase any remaining signs of life. Plants would have died long before, unable to survive without fresh water. Animals would have perished from thirst, heat, or starvation. Even microscopic organisms in the soil and deep underground would fail as the planet dried out completely. The sounds of waves, rain, and rivers would vanish, leaving only the howling of dry winds and the roar of volcanoes. In the final moments, Earth would be a silent, arid world. The basins that once held life and motion would lie empty, their surfaces etched with the marks of boiling and evaporation. The crust, once cooled by deep oceans, would be left bare to the Sunday's relentless heat. From orbit, the planet would look like a burned-out ember, its surface scarred and lifeless. The transformation from a water-rich world to a desert wasteland would be complete, with only traces of salt and steam to mark the oceans that once covered it. Deep inside Earth, molten iron and other metals flow around the solid inner core. This movement generates the magnetic field that surrounds the planet, creating an invisible shield that protects all life on the surface. Without this field, Earth would be exposed to constant streams of charged particles from the Sunday, known as solar wind. These particles are dangerous. They can strip away the atmosphere, destroy electronics, and harm living cells. The magnetic field acts like a barrier, bending these particles away and keeping the surface safe. If chaos disrupted the flow inside Earth's core, this shield could weaken or collapse, leaving the planet defenseless. When Earth began its violent spiral toward the Sunday, the balance inside the core would be one of the first things to fail. The sudden changes in rotation, pressure, and heat would throw the molten metal into chaos. Instead of flowing in steady, predictable patterns, it would churn violently. Imagine a pot of water being stirred smoothly, then suddenly shaken and flipped upside down. The clear currents that once formed would vanish, replaced by turbulence and confusion. This disruption would prevent the generation of a stable magnetic field. Over time, the field would flicker, split, and finally collapse altogether. At first, the collapse might go unnoticed by humans. Compasses would stop pointing north. Migratory animals like birds and sea turtles, which rely on magnetic cues to navigate, would become disoriented and lost. Satellites orbiting Earth would begin to fail as unshielded solar radiation fried their circuits. Space agencies would detect strange readings and bursts of radiation, warning of trouble. But these would only be early signs of a much larger problem. Once the magnetic field was gone, the solar wind would strike the upper atmosphere directly. The impact of solar wind on an unprotected planet would be immediate and violent. Streams of charged particles traveling at hundreds of kilometers per second would slam into the atmosphere. Normally, the magnetic field deflects these particles toward the poles, where they create the northern and southern lights. Without that protection, the entire atmosphere would light up in a constant blinding aurora. The skies would glow red, green, and purple across every region, a beautiful but deadly sign that radiation was pouring through the air. These particles would begin stripping away the upper layers of the atmosphere molecule. By molecule, the lightest gases, like hydrogen, would escape into space first. Over time, heavier gases like oxygen and nitrogen would also be lost. This process would thin the atmosphere, reducing the air pressure at the surface. People and animals would find it harder to breathe as oxygen levels fell. Even before the air was gone, the radiation itself would be lethal. Without a magnetic shield, the Sunday's ultraviolet rays and cosmic particles would strike directly, burning skin, damaging DNA, and causing rapid mutations or death. Electronics would fail almost immediately. Power grids would overload as currents induced by the solar storm fried transformers and wires. Communication systems would go dark as satellites failed and ground. Based antennas burned out. Planes would lose navigation systems and crash. Hospitals, water treatment plants, and other critical services would shut down, plunging human society into chaos. Even if some devices were shielded, the constant bombardment would make repairs impossible. At the same time, the loss of the magnetic field would affect Earth's atmosphere in other ways. The solar wind would push against it, compressing it on the side facing the Sunday and stretching it into a long tail on the opposite side. This constant pressure would create fierce winds and turbulence high above the surface. These changes would alter weather patterns, creating strange and violent storms. Lightning would strike in places where it never occurred before. Rainfall would become erratic, with some regions buried under constant floods, while others dried out completely. The surface would grow hotter as more energy from the Sunday reached it directly. Normally, the atmosphere filters harmful radiation and spreads heat evenly. Without protection, the sunlight would strike with brutal intensity. Deserts would expand rapidly, burning away vegetation and drying up rivers. Ice at the poles would melt almost instantly, flooding coastlines and sending vast amounts of fresh water into the oceans. Sea levels would rise sharply, displacing millions of people and drowning cities. The combination of flooding and radiation would make many regions uninhabitable within days. Living creatures would not survive long under these conditions. Plants would wither as their cells were damaged by ultraviolet rays. Without plants, the base of the food chain would collapse. Animals would starve as their food sources disappeared. Radiation would also cause direct harm, burning tissue and disrupting internal systems. Larger animals might die within hours of exposure. Smaller creatures, like insects and microbes, would survive longer, but even they would eventually succumb to the constant barrage of particles and heat. Humans would try to seek shelter underground or underwater. These locations offer some protection from radiation, but they would not solve the larger problem. Without plants to produce oxygen, underground shelters would run out of breathable air. Without sunlight to grow food, supplies would quickly run out. Even if people tried to grow plants with artificial light, the loss of stable temperatures and clean water would make farming impossible. Disease would spread rapidly in crowded shelters, finishing off survivors who had escaped the initial disaster. The oceans would also begin to change. Solar radiation penetrating the surface would kill plankton and other small organisms. Without these creatures, the marine food chain would break down just as it did on land. As the water heated, gases trapped in the ocean would escape into the atmosphere. Methane and carbon dioxide would pour out, further destabilizing the climate. The oceans would boil near the equator. sending up massive clouds of steam that trapped even more heat. The once cool and life-filled waters would become dead zones of scalding liquid. From space, the planet would look drastically different. Without a magnetic field, Earth would have no protective bubble around it. The solar wind would visibly strip away gases, creating a stream of escaping particles trailing behind the planet. The blue and white colors of oceans and clouds would fade. Dust, smoke, and glowing auroras would take their place. The once stable weather systems would vanish, replaced by chaotic swirls of heat and turbulence. Over time, the loss of the magnetic field would leave Earth more like Mars. Billions of years ago, Mars had water and a thicker atmosphere. Scientists believe it also had a magnetic field generated by a molten core. When that field failed, the solar wind slowly stripped away the air and water, leaving the barren world we see today. Earth's collapse would happen much faster because of the rapid inward spiral toward the Sunday. Instead of millions of years, the atmosphere could be lost in weeks or months. As the last layers of air escaped, the surface would be fully exposed to space. Radiation would pour down unblocked, sterilizing the land. No living creature could survive on the surface. The oceans, already boiling, would vanish completely with no atmosphere. There would be no wind or sound. The surface would grow silent, except for the rumble of shifting tectonic plates and erupting volcanoes. In its final days, Earth would be a bare, cracked sphere with no blue skies, no clouds, and no shield to protect it. The Sunday's radiation would strike directly, heating the crust and breaking down the last traces of water and life. The planet would continue its inward fall, defenseless, until it finally met the star that destroyed it.